Hi, my name is Anna Grace Browning, and today I will be representing myself and Megan Adams. We are two accounting students at the University of Southern Mississippi. So, first off, I want to say happy Halloween, happy spooky season. I hope you have put your skeletons and witches and black cats out. I hope you're eating candy corn. And as you're watching this right now, I want to tell you that today, me and Megan want to talk about our prediction for the temperature on Halloween. So, one of my favorite seasons is Halloween. I can remember growing up going trick or treating every Halloween around my neighborhood, and I would wear these nice costumes. And sometimes one time I was Cleopatra, one time I was Chipper Jones. He was my favorite Atlanta Braves baseball player. Um, but I can always remember having to wear a jacket when it was really cold. The years that it was really cold, I always remember having to wear a jacket. So I thought, me and Megan talked and we were like, what could we do for this assignment? And I said, it'd be really nice if we could maybe predict whether someone would have to wear a jacket. So what we did was we tried to predict whether the temperature for Halloween night would be under 65 degrees. Because once the temperature gets under 65 degrees, it's like, okay, I need to put on a light jacket. So we started by doing a correlation analysis. We went to the NOAA, the National Oceanic and Atmospheric Administration website, and we took data from the years 2000 to 2019. So we ordered data sets for just October 31st. There were 13 different things that they were going to give you the data for. So we picked out five that we thought might correlate, might affect how cold it feels outside. So we chose average temperature, average dew point, average wind speed, precipitation, and maximum wind gust. So we got data from different parts of the state, ranging from Jackson to Gulfport to Meridian, even some Hattiesburg Laurel area data. So we thought we would, instead of focusing on one particular region, we would look at the state of Mississippi as a whole. So once we did that, we formatted our spreadsheet to include the data that we wanted. Well, when looking for the data, when gathering data, we could not find any data collected anywhere in the state of Mississippi for the year 2014. So we decided to exclude the year 2014 from our data set. So after we did that, after we had formatted our spreadsheet, we went on and did the correlation analysis. So when doing the correlation analysis, we wanted to figure out which variables from average dew point, average wind speed, precipitation, and maximum wind gust, which of those four affected the average temperature variable. So after running the analysis, we found that two of our four variables were either highly correlated or very highly correlated with our variable of average temperature. And those were average dew point with a 0.920664758 and average wind speed with 0.506305152. So we then wanted to look and see if there was a correlation between average dew point and average wind speed. We looked and there was a high correlation between those two variables. It was 0.588065528. So at that point, because both of our variables that we found to be correlated or highly correlated with average temperature, since both of those variables were highly correlated with each other, we wanted to pick one or the other. We knew we had to pick either average dew point or average wind speed. So when we looked at the correlation between each of those and average temperature, average dew point had a very high correlation where it was 0.920664758. So that was higher than the average wind speed correlation of 0.506305112. So we went ahead and we chose to look at average dew point. So then we ran our regression analysis. First, we looked at our R-square value, and it was 0.847 or 85%. That 85% tells us that 85% of the average temperature variable is determined by what the average dew point variable is. So we then moved on to looking at our ANOVA table. Our significance F factor was 6.0709 e to the negative 08. So that tells us that our regression equation is good. Then we wanted to develop our equation to figure out what the average temperature might be on Halloween night. So we knew that the dew point affected how high the temperature was. We looked at two scenarios. So our first scenario looked at an average dew point of less than 50. We used 40. At an average dew point of 40, the temperature is 52.6. Then we looked at an average dew point greater than 50. We used 60. So at an average dew point of 60, the temperature was 68.48. So from this, we can see that a higher dew point leads to a higher temperature. We can see that on average, generally, the higher the dew point, the higher the temperature will be, and vice versa. We can see that a lower dew point, a lower average dew point, leads to a lower temperature. So after doing this regression analysis and interpreting its results, personally, I will be looking at the forecasted dew point for Halloween night to see whether the temperature is going to be higher or lower. If they say the dew point is going to be over 50, you can kind of expect it to be a little hotter. You can expect to not have to wear a jacket. If the dew point is going to be less than 50, you can almost certainly say that you're probably going to need to bring a jacket. It's going to get a little chilly. So I hope everyone out there has a great Halloween. Have fun trick or treating. Be safe and check to see if you need to bring a jacket. Stay warm.